This video is going to cover critical loading for influence lines. We're going to pick up right where we left off in the influence lines video, where we've already solved for the influence line for By and the influence line for M at C, so the moment at C. And now we want to find what's the loading case that's going to create the maximum vertical reaction for By and the maximum negative moment at C specifically. We're going to have a dead load that's 3 pounds per linear foot. We're going to have a live load that's 10 pounds per linear foot. And we're going to have a point load, just one point load of 25 pounds. Now we can put these where we want for the most part. Remember that a dead load and a live load, they act over an area, right? Because they are in per linear feet here. And a point load is just pounds. So the point load here is going to act at a singular point, which is going to have a singular value. However, the live load and the dead load here, since they act across an area, they're going to be times the area of the influence line. So to start with the dead load we really don't get a choice. The dead load is mostly the self-weight of the beam. So he is going to act across the entire beam. We really don't get a choice. So this is our dead load. As far as the live load goes, we can choose where we want to place him. If we want maximum By, for this instance, we want to maximize the positive area on our influence line chart. So that means that I'm going to have my live load only on this side. That's going to give us the most positive area under that influence line. And then lastly, we have a point load, and that point load acts across a single value. So I'm going to be looking to find the highest positive value, since I want maximum By, on my influence line. So that's this guy over here. So I'm going to load my point load right at that spot. So that's my loading situation. Now let's calculate what is maximum By. So By maximum is going to equal, first up we have the dead load. Right, so the dead load was 3 pounds per linear foot times what's the area that the dead load acts across. Well, he is going to act across both the negative triangle there and the positive triangle. So for the negative triangle, that's 1/2. The base is 6 feet. The height is negative 0.333. So not too good there. It's going to subtract a little bit. That's okay. Then we also have the big triangle. So we have 1/2. The base there is 9 plus 9 plus 9. That's 27. Times the height of that triangle goes all the way up to 1.5. So all of that is the dead load. Then we're going to have the live load. The live load was 10 pounds per linear foot times the area under his curve. That's just going to be the positive one. So it's 1/2, the base of 27, the height of 1.5. Then we've also got the point load. Forgot to say that we're adding these. We're adding in the point load. The point load we said was 25 pounds. And again, he only acts at a point, and that point was 1.5. So if we add all of that up, we're going to get that By maximum is equal to 298 pounds. So that's effectively what we're going to do. If we want maximum negative moment at C, it's going to be kind of the same thing. The dead load, we don't get a choice. Dead load just kind of acts across the entire thing. You can't say that the self-weight of the beam doesn't exist because you don't want it to, right? He always exists. So the dead load is what the dead load is. The live load can be anywhere we want it to be. So he can act over all or part. So we want maximum negative MC, so we want to maximize our negative triangles here. So we're going to put our live load across just that area. And the other area is over here. So that's our live load. And then again, we have a point load. We just said we have 1 point load. If we had 2 point loads, we could maximize 2 different spots. But we have 1 point load. So our 1 point load, we're going to pick our biggest negative. That's this guy right here. So our point load is going to be on this side. It's just 1 point load. So if we want to find maximum negative moment at C, we have MC max negative specifically. For the dead load is 3 times, we have 4 triangles technically. Well, 3, but 4 if you want to do the right angle ones. So we've got 1/2 the base of 6, the height of -3, plus we're going to have 2 of this triangle. So 1, 2. So we're going to have 2 of 1/2 the base of 9, the height of 4.5. That's the height there of our triangle. Plus, we've got 1/2 the base of 9, the height is -4.5. All of that times that dead load. A lot of the stuff there for that dead load. Plus, we've got the live load. So the live load value, he's going to be 10 times, he's got 1/2 the base of 6, the height of -3. Just doing the negatives now. Plus 1/2 the base of 9, the height of -4.5. Then we have the point load. So plus our point load was 25 times his negative number of 4.5. So our maximum negative moment at C is going to be, I'm just giving you a value here. This maximum value is 371 pound-feet. I mean, technically he's negative, but the maximum value of it is 371 pound-feet. So that's all that there really is to critical loading.